Coulomb's torsion balance. Charles Augustin de Coulomb measured the magnitudes of the electric force. Coulomb's torsion balance is an instrument that enables. He placed the sphere back into the balance. The sphere and the brass disc. Coulomb found that the force between 2-point charges was directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance between them. Mathematically, if two
Gauss's law. Carl Friedrich Gauss, a German mathematician, gave a law named after him that gives the relationship between the electric flux.
Electric field lines. Electric field lines, invented by Michael Faraday, are a way of pictorially mapping the electric field. Let us see the nature of lines of force around some simple charge configuration. The lines of force between two like charges seem to exert sideways pressure, showing that like charge. The lines of force between two unlike charges tend to contract lengthwise, showing that the unlike charges attract.
What is static electricity? Observe these visuals. What is this due to? This static electricity was first. What exactly is happening when two materials are rubbed together? When two materials are rubbed together, electrons from one material are knocked out and are transferred to the other. The material that loses electrons gets a. Observe the demonstrations to understand the nature of electrostatic charges and their interactions. Electrify two plastic rods by rubbing with the same piece of fur. Here are some simple experiments with static electricity which you can try at home. They work best on cold. Watch what's happening. Rub an ebonite rod with felt. Suspend the charged ebonite rod as shown here. Bring a glass rod rubbed with silk close to the ebonite rod. Both the rods attract, showing that they have unlike charges. Now, rub the glass rod with acrylic and bring it close to the charged ebonite rod. The rods repel each other, showing that they have like charges. This shows that the charge acquired by a body depends on the nature of the. Displayed here is an electrostatic series arranged in terms of the relative hold that different materials have on their electrons. Under ideal conditions, if two materials are rubbed together, the one higher on the list holds electrons. You will learn Coulomb's law. Coulomb's law in vector form. The electric force between two stationary point charges is directly proportional to the product of their charges and inversely proportional to the square of distance between them. Mathematical implications of Coulomb's law. Force is directly proportional to two charges and inversely proportional to the square of distance between them. Forces exerted by charges on each other are equal in magnitude and opposite in direction. The principle of superposition, which is the basis of interaction for multiple charges. The total force on a given charge is the vector sum of the forces exerted on it due to all other charges. This is based on the principle of superposition. The total force acting on Q1 is given by the vector sum of the interaction between multiple charges based on the principle of superposition. You have learnt Coulomb's law and its vector form, conservation of energy between charges, principle of superposition of charges, force acting on a charge in a system of three charges. You will learn about conductors and insulators. Difference in concept of conductors and insulators. Any metal rod held in hand and rubbed with wool will not show any sign of being charged. If this metal rod with a wooden or plastic handle is rubbed with wool, it shows the sign of charging. Definition of conductors and insulators with examples. Some substances readily allow electricity to pass through them easily are called conductors. Some substances offer high resistance to the passage of electricity through them. Such materials are called as insulators. Motion of charges in conductors. When some charge is transferred to a conductor, it distributes over the entire surface of the conductor. Charge can be moved from one place to another using conductors. The inability of charge to move in an insulator. Insulators are a flexible coat of material on electric wires and cables that does not allow electric charge to flow through them. When we bring a charged body in contact with the earth, all the excess charge on the body passes into the ground when connected through a wire. The process of sharing of charges with the earth is called earthing or grounding. Semiconductor materials offer resistance to movement of charge. You have learnt substances which allow electricity to pass through them are called conductors. Substances which do not allow electricity to pass through them are known as insulators. Charge can be moved from one place to another by conduction. Insulation does not. You will learn continuous charge distribution, surface, linear, and volume charge density. Charges reside on the outer surface of a conductor. When two charged bodies enclose each other, then charge transfers from one body to another. For a continuous charge distribution, the total charge is closely bounded together within the less space between the charges. The surface charge density is defined as total amount of charge per unit area. The formula for surface charge density at the area element is sigma is equal to delta Q pi. Linear charge density is defined as total amount of charge per unit length. The formula for linear charge density is lambda is equal to delta Q by delta I. Total amount of charge per unit volume is linear charge density. The formula for volume charge density is ρ is equal to delta Q. The electric field due to a continuous charge distribution can be obtained in the same way as for a system of discrete charges. By using Coulomb's law and the superposition principle, electric field can be determined for any charge distribution, discrete or continuous, or part discrete and part continuous. You have learnt about a continuous charge distribution. linear charge density, you will learn charging by induction. Charge obtained by body without actual contact of any charged object is termed as charging by induction. Nature of the material and its capacity to acquire charge are the key factors while charging a body by induction. Atomic behavior while charging by induction. An atom has positively charged proton in the nucleus and negatively charged electrons revolving around the nucleus. When electrons jump out of the atoms, then the object gets charged up. Experiment for the process of charging by induction. Two metal spheres, A and B, supported on insulating stands are in contact with each other. Bring a positively charged metal rod near one of the spheres, taking care that it does not touch the sphere. The free electrons in the sphere are displaced towards the rod. Displacement of subatomic particles in the process of charging. The metal spheres will be equal and oppositely charged. This is charging by induction. You have learnt Introduction to Charging by Induction. You will learn basic properties of electric charge. Charge can be either positive or negative. A body attains positive charge when electrons are removed from it and attains negative when. Properties of electric charge. Magnitude of elementary charge is equal to plus or minus 1.6 into 10 to the power minus 19 coulomb. The electric charge of the system is always conserved. Additive property of electric charge. The total charge on an object is the algebraic sum of the charges located at different points in the object. The total charge is the algebraic sum of all individual charges in the object. Conservation of electric charge. For any isolated system, the net charge remains constant. Within an isolated system consisting of many charged bodies, due to interaction among the bodies, charges are redistributed. It is not possible to create or destroy net charge carried by any isolated system, although the charge-carrying particles may be created or destroyed in the process. Numerical based on additive property of charge. You have learnt electric charge and properties. Additive nature of charge. You will learn the electric flux is a product of the magnitude of the electric field E and surface area A perpendicular. Gauss's law of electrostatics states that the electric flux through a closed surface S is equal to 1 by epsilon naught times the total charge enclosed by that surface. Important points to remember while using Gauss's law to derive the equation for electric field. Gauss's law is true for any closed surface. The surface that we choose for the application of Gauss's law is called the Gaussian surface. However, the Gaussian surface can pass through a continuous charge distribution. Applications of Gauss's law. Gauss's law is often useful towards a much easier calculation of the electrostatic field when the example of how electric flux is measured through a cylinder. You have learnt Gauss's law infers the amount of enclosed charge You will learn the electric charge is a basic fundamental property of matter carried by some elementary particles. Positive and negative are two. Electric charge is generated by friction. Due to mechanical friction, the electrons are torn from the atoms. Electric charge is said to be quantized. Charges of larger magnitudes are built on an object by adding or removing electrons. An example to understand that electric charge is quantized. Electric energy is said to be conserved. Law says that the total electric charge of an isolated system is constant regardless of changes within the system itself. Total electric charge of the system is equal to algebraic sum of the electric charge located in the system. You have learnt electric charge is a basic fundamental property of matter carried by some elementary particles. You will learn about fundamental particles of atom are protons, neutrons, and electrons. Protons are positively charged. The number of electrons that surround the nucleus will determine the electric charge on the object. If atom contains process of electron flow to acquire charge. Electrons can migrate from one orbit to the other within an atom and also from one atom. Electric charge is quantized. Unit of charge is coulombs. Properties related to electric charge. We can charge an object either by conduction, friction, or induction. When two substances are rubbed together, numerical defined number of electrons. You have learnt electric charge. Property. You will learn the property of a material or a substance that causes it to experience a force when brought close to another electrically charged body. An object gets charge when it either gains or loses electrons. Early experiments to charge a body by conduction. If an object possesses an electric charge, it is said to be electrified or charged. Gold leaf electroscope is used to detect the charge on the body. The apparatus consists of a vertical metal rod with a knob on the top, housed in a box having two thin gold leaves attached to its bottom end. The box and rod are insulated by a non-conducting material like rubber. Simple electroscope that can be constructed using a bottle, cork, and metal rod. When a charged object is brought in contact with the metal knob at the top, the charges flow through the rod to the leaves. Paper strip experiment to demonstrate like charges repel. A strip of paper and fold it into two halves. Open the strip and iron it lightly with the mountain fold up. Hold the strip by pinching it at the fold. You have learnt electric charge. You will learn Gauss's law. Flux through a sphere. Gauss's law gives the relation of distribution of electric charge to the electric field. Gauss's law states that the electric flux through any closed surface is proportional to the a sphere with radius r and point charge q is considered. Sphere is divided into small area elements. Coulomb's law for electric field due to charge q is used. The unit vector r is along the radius vector from the center of the object to the area element. Area element and vector element have the same direction. Magnitude of a unit vector is 1. To obtain the total flux in the sphere, the flux in different area elements are summed up together. S is total area of the sphere is 4 pi r squared. Electric flux through a closed surface S is equal to Q by epsilon naught. The total electric flux through a closed surface is 0 when no charge is enclosed by the surface. The electric field is uniform and is in closed cylindrical surface which is parallel to the uniform field E. Total flux phi through the When the net electric charge inside a closed surface is 0, the total charge contained in the closed surface is 0. Gauss's law holds good for closed surface. Charges will be present anywhere in the closed surface. Closed surface has charges inside and outside the surface. Electric field is calculated considering both the charges. The surface which is used for the application of Gauss's law is called Gaussian surface. Gaussian surface is chosen and Gauss's law can be applied. Gaussian surface has continuous charge distribution. When the system is symmetric, Gauss's law helps in easier calculation of electrostatic field. Gauss's law is based on Coulomb's law. Numerical for Gauss's law. You have learnt Gauss's law relates the distribution of electric charge to the electric field. Gauss's law states that